Assalamualaikum. We are doing some MCQ questions. We are doing some MCQ questions on kinematics. A goods train passes through a station at a steady speed of 10 meters per second. An express train is at rest at the station. The express train leaves the station with a uniform acceleration of 0.5 meter per second square just as the goods train goes past. Both trains move in the same direction on straight parallel tracks. How much time passes before the express train overtakes the goods train? Now, this is the question. Please read the question.
Okay, sir.
A goods train passes through a station at a steady speed of 10 meters per second. An express train is at rest. Now, if I try to simulate there are two trains, a goods train actually passes through a station at a steady speed of 10. So let's make a station here. A train is coming like this. An express train is at rest at the station. The express train leaves the station with a uniform acceleration of 0.5. Second train is at rest and it starts from the. I saw your answer. Let's work out. Did you work it out? Both trains move in the same direction on straight parallel tracks. Leaves the station with a at rest. It's U is equal to 0. And so he wants X overtake. So overtake means they will have traveled the same distance because overtake is possible when they come side by side. So how much time passes before the express train overtakes the goods train? It is going in this way, in this direction, and it's also going here. Suppose this is the overtake position. So when they overtake, the distance from the station, they both will have traveled the same distance from the station. And one train is accelerating and one train is moving at a constant speed. So here it will be D is equal to Vt. And here So I made the two equations.
Sir, is it D?
How much is 10 upon 0.25? Is it 40?
40. Yeah, 40.
So this is how we manage the overtaking questions, and overtaking logic is quite famous.
Okay. Done, sir.
A ball is released from rest above a horizontal surface and bounces several times. The graph shows for this ball a quantity y. This MCQ is famous. It has in AS there is a tradition of repeat MCQs, and normally in a paper of 40 questions, 7 to 9 MCQs are commonly repeated. If you have done a good range of past papers, then you can definitely get a repeated MCQs. He says that when a ball is released from rest above a horizontal surface and it bounces many times. So what I always do, you have seen it, that I always try to simulate the situation that I have a surface.
Yeah.
I have a surface and I drop the ball. Dropping the ball was a very famous case in our old paper. The ball drops and the ball rebounds, then reaches a maximum position, drops, and rebounds. And then it comes down like this. Every time the rebound decreases and the ball goes below that. Now, the options are tested by the logic of the diagram. Now, acceleration, what is the quantity y? The graph shows, number one, the value is not going in negative. The graph is fully in positive. Secondly, the graph shows that the value every time is reaching a constant number. Every time the value is reaching a constant number, but it is now leaving zero. It means it is coming down. Such questions should be done by elimination method. You have to test every one. So if you see number A, acceleration, acceleration can be our option because when the journey is up and down, acceleration is there. When it falls down, when it rebounds, then it falls down. But the problem is that the quantity varies with time. The problem is that y acceleration would be reaching one fixed number, the constant number. Second is displacement. Now, displacement is the separation from the original position. And you can see every time the ball is losing the displacement. Every time ball is losing the displacement, and eventually ball will ground, and when the ball ground, displacement will be zero. Kinetic energy and velocity. Velocity is not a question. Why? Because velocity is a vector. Velocity will change its sign. So if it is positive v, it will be negative v upward. So velocity is out of the question.
Oh,
Kinetic energy is the energy due to motion, half mv square. Kinetic energy also decreases. The graph shows increase and then decrease, then increase, then it decrease. So there is a good tie between B and C. You are selecting B. No, sorry, you are selecting C. B and C are very good ties. So acceleration is definitely wrong. Velocity is wrong. The tie is between B and C.
so it's B.
I have explained it again, and you should look on the approach again. We need an explanation. Why B? Yeah, why C?
So it's gonna be B. It's because like the displacement becomes constant eventually from the thing. So and kinetic energy, it'll eventually become zero as it like stops moving.
Right. That's a very good judgment because kinetic energy, the ball has dropped from the height. The ball has dropped from the height, and this is the perfect point you have picked. Actually, the ball displacement will not become zero because ball is coming down. The journey has started from a downward motion. So even when the ball stops, the displacement will be the final number will not be zero. Kinetic energy will eventually become zero.
Yeah. Yes, sir.
So we put our effort and our answer is B. At time t is equal to 0, a body moves from rest with constant acceleration. People have to make a habit that when you read this type of questions, you should do a working. MCQ papers are like proper working papers. At time t, the body is distance s from its rest position. A graph is drawn of s against t square. Now, this s against t square is a very famous relation. After doing good number of questions, you will remember it for next time that actually the main equation is s is equal to ut plus half at square. So the body has started from rest. So u will be 0. So 0 will be plus 0 plus half at square. So S is equal to half at square. Examiner says that he is plotting S against t square. So it means S upon t square is half at square. Y upon x is called gradient. Gradient is half at square. Gradient is half at square. No, I'm making a mistake. Gradient is, I have, yes, now it's a correction. Gradient is only half a because t square has gone on the other side. After doing some derivation, the graph is drawn s against t square. You have to look
So
for
how
every part. S is equal to half the value of the gradient.
so how
Acceleration,
is so how is ut equal to 0?
because it started from rest now.
Yeah.
0 into t. The
Okay.
object has started from rest.
Okay, understood. Okay, understood, sir.
Now look at the every option. Is it right that if I go for acceleration, let me make acceleration the subject. Acceleration will be 2 times of gradient. So first option is wrong. Acceleration is not half the value of the gradient, equal to value of the gradient of the graph. But acceleration is 2 times the gradient.
Yeah,
So what would be the answer?
it's gonna be B, sir.
How B?
Sorry, C.
Yes.
Because it's
Now,
twice.
B cannot be the answer because it's not equal. Once you
Yeah,
have done,
yeah.
the working, the MCQ is always there to help you. But if you try to do it in the style we people used to in O level, that people used to feel the questions, but this is not the case. A level MCQs are sometimes, many times actually, next level. So
Yes, sir.
we are starting our next question. A car is stationary at traffic light. When the traffic light goes green, the driver presses down sharply on the accelerator. The resultant horizontal force acting on the car varies with time as shown. Initially, resultant force is 0. How it's possible that if you are standing on a road, and I'm drawing a pathetic car actually. This is a car. But I want you to recall for me the forces on a car. This is
The driving force.
the driving force. This is air resistance. This is friction. This is weight. And this is R.
Yeah.
Now, what the question shows that initially, car is resultant force is 0. It means that the driving force will be equal to the resistive forces. So the car won't be able to accelerate. The concept of resultant force is there. So initially, when the car is trying to move, the resultant force is 0 here in this part. Acceleration is 0 and resultant force is also 0.
Yes, sir. So
Resultant force suddenly increases and then resultant force becomes constant. Remember that the
yes, sir.
trend of resultant force is the trend of acceleration. Resultant force is directly proportional to acceleration. So the behavior of resultant force is the behavior of acceleration. Initially, resultant force is 0, so acceleration will be 0. When you say force increases, acceleration increases. When you say resultant force becomes constant, then acceleration will also becomes constant. So
Yes,
there are
sir.
3 stages. 0 acceleration. I draw it here. Acceleration 0, then acceleration increases, and then acceleration becomes constant. Now you have to select the answer for me.
So is it
Remember,
C or D?
speed time graph is always the gradient of speed time graph is acceleration.
Sir, is it C or D? I'm leaning towards D, sir.
Okay. What about option A? The speed is initially 0 and then speed increases. That's wrong.
Yeah, it's because like it's gonna become the gradient has to become like horizontal 0. The gradient has to become 0 as like
speed is 0, and later the speed is rising. So initially, if I mark my A, velocity is 0, and here, when the line is a slope means acceleration is constant.
Yeah.
Here, velocity is 0, and here, acceleration is increasing. Here, velocity is 0. When velocity is 0, acceleration is also 0. Acceleration is 0, and then velocity becomes constant and acceleration becomes 0 again.
Okay.
Here, velocity is 0, acceleration is 0. Here, velocity is constant and acceleration becomes 0. I have worked out all the sketches, and I have the description of the situation, what I want. Now, which of the graphs matches with my box?
D, sir?
How D?
Because acceleration is increasing.
Acceleration increasing, no doubt. But what's happening in the end? Acceleration is 0. But what's happening in the real situation?
The V is constant. Acceleration is 0, so V is constant.
Not 0. In my target question, acceleration is constant.
Okay.
That is right. This one part has a variable acceleration. So I need a graph which shows acceleration is 0, and in the end, acceleration is constant.
So A, sir?
A is the right answer. Very good.
Okay, sir.
One object moves directly from P to R. One object moves directly from P to R. Let me simulate P to R. So P in a shorter time, a second object moves from P to Q to R. The second object goes P to Q and then Q to R.
So is it C?
Let me see. Which statement about the two objects is correct for the journey from P to R? Looks like a vector diagram. Which statement about the two objects is correct for the journey from P to R? They have the same average speed. The other object is traveling in a shorter time. It means we can expect that they are reaching together. You say the shorter time, it means the other person is moving at a faster speed. So we can think on that. Same average speed. Average speed is total distance. Average speed is total distance upon total time. I've written the formula. Acha, average velocity is resultant
Displacement.
Displacement upon
total time.
now they have the same displacement. Displacement is in a straight line. Do you think that the other particle is going from the other routes, but reaching on the same position? They have the same starting and ending point. They travel the same distance. Do you think D is possible while the other object is going through a bigger, longer route?
No, sir. So
No, no.
D and A are crossed out.
So D is out of the discussion. They have the same average speed. If we cancel D, automatically A will be cancelled out. Because average speed is total distance upon total time.
Yeah.
When distance is not the same, even if the time is the same, it will not be equal.
Yes, sir.
So we have a tie between B and C. Now here you have to take the sense of A level that because both of them are possible, frankly speaking. Average velocity can also be the same, but that word is used in a shorter time. The time is same or not?
No, sir.
Time is
Shorter.
not. When time is not same, then average velocity is also out of the discussion.
Yes, sir.
So that is also possible. Now, only C left out. And why logically it is the right answer? Logically, it is the right answer because displacement is a vector. And no matter how many routes you take, the final and the initial position is the same. The graph shows how velocity varies with time for a bungee jumper. Who is this bungee jumper? Have you ever tried it, bungee jumper?
No, sir. It's
Question from the-
people who jump off cliffs, sir, with a rope.
Do they have a string with their string tied up?
Yeah, on their feet, sir.
And when they fall, the string is elastic.
Elastic, I don't think so, sir.
It's elastic. Otherwise, if you tie someone from the feet with a rigid string, then the person might lose the feet. So they jump from that's why they go down a bit and then they come up. That's why we use the word bungee jumper. So let's simulate the situation. This is our string and let's see, this is the person, this is the person. And read the graph, look at the graph. Can you see the velocity initially increases?
Yes, sir.
At the highest point, velocity will become maximum and acceleration will be 0. So it's going down, velocity increases. It is the case when you are falling freely. Am I right? Nearly freely. The graph
Yeah.
is not a straight line. What happens at Q?
Velocity is increasing, sir.
Q velocity is max. What is the concept of gradient at the turning point?
Gradient is equal to 0, sir, at the turning point.
Always, this is the concept to remember that at a turning point, gradient is always 0.
Yes, sir.
So Q is the then can you tell me what's happening Q to R? Velocity is
Due
decreasing.
to R, velocity is decreasing, sir, yeah.
Velocity is decreasing. It means that the string is in action.
Sorry, sir.
Velocity is decreasing. It means string is getting taut.
I think so.
Because if you have seen that video anytime, you can see initially they go like a free fall, they go accelerating, and
Yeah.
then the string is getting taut, the velocity decreases, and then what happens at R?
Velocity becomes 0.
Yes, it's a U-turn, velocity becomes 0, and then after that, is it right that it will be a U-turn?
No, it can like acceleration could also decrease.
No, but why velocity would be negative if there is no U-turn?
Sir, because the object goes in the opposite direction,
So
goes
it
back up.
velocity will become 0 here, and
Yeah,
then
it goes back up.
the person or the object is now going upward.
Yeah, that's what I'm
During the
saying.
upward motion, velocity will become negative, and during the downward motion, velocity is plus. So I have
Yes, sir.
changed the situation also. We have thoroughly discussed the graph, at which point is the bungee jumper momentarily at rest, and which point does she have zero acceleration. So I have done the whole working with you, and now you
Yeah,
can the column.
at rest. Sir, at rest is gonna be R, and with zero acceleration is gonna be Q. So C.
C, rest at R. Very
Yeah,
good.
because yeah,
And jumper with zero acceleration. So very good judgment, C. But look at the size of effort needed to solve an MCQ. And sometimes people feel after doing some papers that paper 2 is more manageable here as compared to paper 1. You need to think a lot. The graph shows how the velocity of a firework rocket changes with time. At which point on the graph does the rocket have the greatest acceleration? Now, this is a
B,
very
sir.
technical question. For
Sir,
that,
it's just you just have to find the gradient. Yeah, so it's just gonna be B.
no, actually, the word is not gradient because the word is our theory. In a motion, when velocity is max, acceleration is 0. When velocity is max, acceleration is 0. And when velocity becomes 0 at a U-turn, when velocity becomes 0 at a U-turn, it is a case when acceleration is maximum. You might remember that cliff diagram, which I had explained 2 times in the normal class. Again, can you tell me what is happening A to C? Velocity increases.
Yes.
A to B,
Okay.
acceleration increases. B to C, acceleration
Decreases.
increases. What happens at C?
Acceleration becomes 0.
Yes, very good. Velocity is maximum, acceleration is 0.
Yeah.
Now, C to D. C to D, the line is going downward, so velocity is decreasing. Am I right?
C to D velocity decreases. Yeah.
C to D, velocity is decreasing. C to D, velocity is decreasing. And the gradient is getting steeper. So it means acceleration is increasing.
Yeah.
Now, what's happening at D? Is it right that D is a U-turn?
Um.
The U-turn.
Yeah. It is a U-turn, I think,
How come?
because it's going back up. The velocity is becoming negative.
Velocity is changing from plus to minus.
Yes.
So I have explained the whole graph with you, and now you can pick up the answer.
It's gonna be B, sir.
B is the right answer, but why?
It's because the gradient is the greatest at B. So like, and
Because
gradient.
the slope acceleration is maximum at D also, but if we draw the slope, if we draw the tangent,
Yeah.
if we draw the tangent, here is the tangent. This is the slope. And if we draw a slope at B, because options are between D and B, but B would have a steeper gradient. So answer is B.
Yes, sir.
An aeroplane travels at an average speed of 600 on an outward flight and 400 km per hour on a return flight over the same distance. What is the average speed? What's the formula for average speed?
Average speed is half U plus V.
So that's the formula is total
It's D, sir.
distance. Total distance upon total time.
Oh, sir, we don't have total time now. So like we have to like search for average velocity, no?
You can you want to try half U plus V.
Yeah.
Okay, then try it.
I'm getting 500, sir.
But 500, let's double check, because half U plus V is actually a formula when an object is moving in one direction. It's an outward journey 600 and an inward journey of 400. Distance is overall the flight over the same distance.
Okay.
So now can you try double check 31? C and D are very close. A is 111, B is 161. I want to still test the main formula. Average speed is total distance upon total time.
Well,
What's the formula of
sir,
speed?
sir, we don't have total distance or we don't have total time either.
Speed is equal to distance upon time.
Yeah.
And we have the speed. 600
Yeah.
for the inward. Will it be right if I say distance is equal to speed into time? So
Yeah, it is. Yeah, you're right, sir.
And it is 600 kilometer per hour on an outward flight and 400 kilometer per hour for the same distance. So if I average speed of 600 and 400 on the distance is the same. So if I want to find the total distance, it will be 2. I can take it 2x. And total time,
But sir, we don't have time. That's the thing.
I know, but I'm trying to solve it from algebra, because you know what? I have the word same distance. Okay, so let's say this distance is x. So if I want to try the upper formula, I can write it 2x. Am I right?
Sorry, sir.
Why it is 2x? Why I have taken 2x?
Sir, is it just distance?
But why? No, but why I've taken the journey the same distance x, because the return flight is on the same. And I'm taking a double check by 1 upon 600, 1 upon 400. X will cut. Now, can you solve this remaining equation for me using a calculator?
It's 104, sir.
Final answer.
One sec, one sec, one sec, one sec.
104 is not even an answer.
It's 480, sir.
It's coming 480. C is the answer. Why I didn't take half U plus V? Note this word, return flight. Half U plus V, what is U?
Oh, U is
U is
U
initial
is
velocity, and what is V?
final velocity.
Now, did you get the point?
Yeah, I got it, sir.
If an object is moving in a straight line, its initial velocity is given, and for the same direction, the final velocity is given. That formula works there. This question is a very good example how A-level MCQs are differing from our O-level ones. And that is why you can see how close he kept C and D. Anyways,
Sir, what is even? What is X even?
X is the distance. The aeroplane went forward for X, came back X. So what would be the total distance?
2x.
X.
Okay, understood, sir.
Anyways, that's a good question, and we stop here, and we will inshallah continue in our next class. Thank
Okay,
you.
sir.
Allah Hafiz.
Assalamu alaikum. Allah Hafiz, sir.